In this video, we're going to continue talking about factoring trinomials, but in this case, we're no longer talking about the trinomial without a number on the x squared term. Now, all these examples in this video are going to have some coefficient other than 1 in front of the x squared term. So let's talk about this one first. We want to factor this trinomial into two binomials. Of course, the first thing that we always do is we always see, can we factor anything out of these three terms? There's nothing we can take out of this one, so now we go on to this step where we start talking about how can we factor this into two binomials. So the first two terms, they need to multiply to get 2x squared. So really our only options, our only good options, are 2x and x. Now when we go to FOIL this thing out, we multiply our first two terms together and we get 2x squared. That's the first term, so that's going to work. Again, these last two terms have to multiply to get 3. Now the order actually matters in this case. We have two options. We have the option of putting a +1 here and a +3 here, or we have the option of putting the +3 here and the +1 here. Now keep in mind we still do have the option of putting -1 here and -3 here, because -1 and -3 still multiply to get +3. However, those don't really make sense in this case because this middle term has a plus sign on it. But I'll write those two options below, and I think we know right off the bat if we start to think about foiling these things out, we're going to get negative values for our middle terms, and that's not going to make sense. It's not going to match up with the positive 5x. So we know that that doesn't work. We know that that option doesn't work, but they are options. Now, which one of the two remaining ones works? Well, sometimes you just have to look at it and figure it out. If we multiply the first two terms together, we get 2x squared, as we intended. We multiply the outer two terms together, and we get 6x. We multiply the inner two terms together, and we get +1x. And if we multiply the last two terms together, we get +3. So obviously the 2x squared term makes sense, and the 3 term works out. But is 6x plus 1x going to give us this middle term here, this 5x? It's not, so we know that that example is not going to work either. So it better be this one or else this thing can't be factored at all. Let's check it. First two terms give us a 2x squared. The outer two terms give us a +2x. The inner two terms give us a +3x. And the last two terms give us a +3. That actually does work, so we know that the correct answer in this problem, the correct way to factor this, is 2x plus 3, quantity times x plus 1. Now, as you might imagine, factoring these kinds of trinomials can get a little bit complicated, especially when there are more than one possibility for how to get this first term. So let's take a look at this example. The first thing you always want to do is ask, is there anything I can factor out of every single one of these three terms? Since the answer is no, we have to move on and try to factor this using two binomials. So we know that there are a couple possibilities. We could put a 10a here and an a here, and that would give us our first term of 10a squared. Another entire group of possibilities, I'll put it down here, is going to be to use the numbers 5 and 2. Now if you're going to FOIL out these two terms, 5a times 2a would also give you a 10a squared. Now we know that this middle term is going to be negative, so that's going to narrow down our possibilities here. For example, we wouldn't think that putting a +1 here and a +3 here would make any sense because we couldn't get a negative middle term. So our possibilities now are -1 and -3, or -3 and -1. So we have the option of putting a -1 here and a -3 here, or a -3 here and a -1 there. Those appear to be our only really good options. Now which one is correct? And as you check more and more of these, you'll get faster and faster at this process. You know that every one of these examples is going to give us a 10a squared as the first term. And you know every one of these examples is going to give us a +3 for the last term. So really the question is, which one of these examples is going to get us that -11a that we need? Well, you just have to try it out. If we FOIL this thing out, you get 10a squared. The outer terms give you a -30a, inner terms give you a -a, and a plus 3. I think it's pretty clear that that one's not going to work because negative 30a minus a is not going to give us this negative 11a. Our second option is 10a squared. Outer two terms give you a minus 10a. The inner two terms give you a minus 3a. And the last term, of course, gives you a plus 3, but that's not going to work either because the minus 10a and the minus 3a don't add up to negative 11a. So hopefully it's one of these guys down here. We could get 10a squared minus 15a minus 2a plus 3. That also doesn't work. Negative 15 minus 2a does not add up to negative 11a. And our last option, this one better work, is 10a squared, outer two terms, multiply the inner two terms, and you'll notice that negative 5a minus 6a is going to give us that middle term of negative 11a. So this one is correct. I personally actually kind of like this guess and check method that we're using here because as you do this more and more, you really don't need to write out every single term that I wrote in blue out here. A lot of times you can look at this and you can kind of do it in your head and you can see if it's going to work. So the more you do it, the faster and faster you get. But sometimes you'll run across problems that maybe there are just so many options that you don't really want to check them all. So there's a technique that can handle those types of things. Okay, so let's say you come across a problem. You have a trinomial and you can't factor anything out of all three terms. And you're sitting there looking at it and you think, man, I don't want to guess and check. I think there are just too many options and I think it would take too long to guess and check. Here's another technique that you can use to factor these trinomials. What we're going to do is we're going to take the first term, the leading coefficient as we call it, the coefficient on the squared term, and we're going to take the number, the constant term as we call it. We're going to multiply those two things together. That's going to give us 9 times 5, and in this example we get the number 45. What we want to do now is we want to make a list of numbers that multiply to get 45. For example, 9 and 5. Two numbers that multiply to get 45 would also be 3 and 15, and 1 and 45 is an option as well. Now you look at that list and you ask the question, which pair of numbers adds up to this middle term here? Well, I think it's pretty clear that the pair that adds up to the middle term is 9 and 5. 9 plus 5 is 14. So what we do now is we actually rewrite this trinomial in 4 pieces. We copy down the first term. We split up the 14t into a 9t plus a 5t. And we're just going to copy down the last term, that was just a 5. So we've rewritten our polynomial. As you can see, these two lines are the exact same thing, it's just we split up 14t into a 9t plus 5t. Now what we can do is we can proceed by using factoring by grouping. And there's a factoring by grouping video just a couple of videos ago that shows you how to do this. What we do is we group the first two terms together, and we group the last two terms together, and we factor out what we can out of each one of those two groups. So the first group we can take a 9t out of, and we're left with a t plus 1. The second group we can take a 5 out of, and we're left with a t plus 1. And hey look, the two things in the parentheses are exactly the same. That means that we can factor that out. We can factor the t plus 1 out of each one of those two terms, leaving us with a 9t from the first term and a 5 from the second term. Not too bad. That's an option of how to factor trinomials. Okay, here we have a slightly harder example. The reason this is a little bit harder is because we have to do one step first. What we have to do first is factor something out of all three of these terms. Now you notice there's a t squared in every one of those terms, so you can factor out a t squared. You'll also notice that there's a negative sign on this very first term. Usually when that's the case, your life will be a little bit easier if you just take that negative out of the parentheses as well. So we're going to factor negative t squared out of everything. If we factor negative t squared out of the first term, we're left with positive 14t squared. The second term is going to be actually a negative 19t, and the last term is just going to be a minus 3. So now in every step we do from here on out, we can just leave this negative t squared out here outside the parentheses. But what we need to do now is continue and factor the trinomial that's left. I'm going to go ahead and use the grouping technique that we used in the last example. That means we're going to take the 14 times a negative 3. That gives us negative 42. Now we need to write down a list of pairs of numbers that multiply to get negative 42. So we'll start with negative 1 and 42, and negative 42 and positive 1. Also, negative 2 and 21 multiply to get 42, and negative 21 and 2 do as well. We can keep going. Negative 3 and 14, as well as negative 14 and 3. Let's see, 4 doesn't work, 5 doesn't work. 6, negative 6 and 7, and negative 7 and 6. And that should be our complete list. Now what we're looking for is two numbers on that list that add up to negative 19. You'll notice the pair of numbers that adds up to negative 19 is that one right there. So I'm going to leave the negative t squared outside, as we will in every single step from here on out. And we're going to rewrite this trinomial, and we're going to split up the middle term into two terms. We're going to split it up into a negative 21t and a plus 2t. Now these four terms here can actually be factored by grouping. We can group those first two terms together, and we can group those last two terms together. What can we factor out? Getting a lot of parentheses here. What can we factor out of the first group? Well, it looks like we could actually take out a 7t. So we're going to pull a 7t out of this first group of parentheses. If we do that, we're going to be left with a 2t minus 3. It doesn't look like we can factor anything out of this group of parentheses here. We're actually, technically we would factor out a 1, I guess you could say. But we can't really write it any differently. We have a 2t minus 3. Now, we have two terms, and they both have a 2t minus 3 on them. So that means we can pull a 2t minus 3 out of each one of those two terms. And what's left from the first term is a 7t. And what's left from the second term when you divide this 2t minus 3 out is just a 1, or a plus 1. Okay, let's try one more difficult example. This one's a little bit different than the previous ones. This time we have 5s squared plus 2st minus 3t squared. We want to factor that. Well, it looks a little bit more complicated, but we start with the same premise. We want to factor this into two binomials. You'll notice that you can't factor anything out of all three terms. The first two terms in both binomials, one option is 5s and s. Now the last terms in both of these binomials have to multiply to get negative 3t squared. So you need to write down some options. Negative 3t and positive t. Those terms would multiply to get the last term. And there are lots of other options too. For example, you would get a different polynomial if you used positive 3t and negative t. You'd get a different polynomial if you used negative t and positive 3t in that way. And you'd get a different polynomial if you used 5s plus t and s minus 3t. Now the question is, which one of these is correct? Well, the goal is to get this middle term correct. Let's see what happens. If we start to FOIL this out, we of course get 5s squared. The outer two terms give us a plus 5s times t. The inner two terms give us a minus 3ts, and the last two terms give us a minus 3t squared. Okay, now we actually got pretty lucky on this one because the first one we tested was the correct one. The 5st minus 3st is going to give us this middle term of 2st. And you can multiply these guys out for fun just to kind of see what would happen. You would get some different results. You wouldn't get the polynomial that we have above. So this is our solution for that problem. Okay, here's your video quiz. Factor each one of these polynomials. You have 20y squared minus 25y plus 5. And you have 9a squared minus 3ab minus 12b squared. Now don't forget the first step when you're factoring any polynomial. It's to look to see if there are any common factors you can take out of everything right off the bat. That'll be important. All right, good luck.